Hello dear students, today let us take a look at the advanced questions for the concept pressure. So we are having what do you call concept MCQs, mains MCQs and advanced MCQs. So in advanced MCQs we have all this which I'll be explaining you. I'll only be taking up this question for YouTube. The rest of the questions will be uploaded in the application. Okay. So about the application, which is the upcoming product, I'll make a video on that also. So for now, let us go to this question from JEE Advanced. Okay. So the first question, a spherical body of radius r consists of a fluid of constant density and is in equilibrium under its own gravity. So this is a spherical body of radius r, okay, and it is a fluid. Think of it like water, okay. It is in equilibrium under its own gravity. So it is in equilibrium under its own gravity. You can think of it like a planet of water. If PR is the pressure at R lesser than capital R, so capital R is a radius, at any point if P is a pressure, the correct options is. So what is the ratio of pressures at different points? What I've done is I've cut the planet and made it into two. Okay. Now, suppose this is a center, and at some r, at this point, what is the? We need to find what is the pressure at some point r. Now, suppose we are taking a small mass here, dm, okay, and the force acting on this mass is what? This is one big planet, right? So on this mass, the force acting is a gravitational force due to the other liquid here. So on this, there is a gravitational force dm into g. Okay. Now this part of the fluid which is there, it is in equilibrium. How is it in? What are the other forces which are there? Suppose here the pressure is some P. P up into some delta A. Let's say the pressure here was P up. So P up into delta A is a force downward. And from here, the force in this direction will be P down into delta A or dA, not delta A. Now, if which one will be more? Tell me, will P up be more or P down be more? Okay. See, you think of this question like this. There are many blocks which are there like this. Okay. There are many blocks like this. Now, on each of this block, there is gravitational force acting. So, where will the pressure be more? Here will the pressure be more, or here will it be more, or here will it be more? We can say that the pressure here will be more, right? Because the weight of the whole thing is acting on this. Similarly, the pressure here will be more and here it will be lesser. Okay, and slowly as we go up and up, at the end, there is only, there is no other material there to push it down. So pressure at R, that means at capital R, P at R equal to capital R will be equal to 0. Okay, so this is one thing that you need to remember. Now we can just raise the force balance equation. What will it be? Tell me. Let us say the pressure is dP here. So what can we write? So here dP into the difference in pressures into area equal to dm into g. Okay. Now dP into dA equal to, what is the mass here? Tell me. Mass is volume. Volume is nothing but area times dA times dr. Okay, area times this height. So at r, this height is dr. Okay, area times r into density, volume into density into what is g. The gravitational acceleration at this point will be g, mass of the planet, r divided by r, gmr by r cube will be the gravitational acceleration at this point. Now we can just cancel out these two. Okay, so dp will be equal to gm rho by r cube into r dr. So now what we can do is at different points we can find what is the pressure. So let's just integrate this. At r, at small r equal to capital R, what was the pressure here? Tell me. It is 0. Okay, and at r equal to some r, the pressure is some p. Okay, and now we can get an expression of p, the what you call relation of p with r. So what will we get here? Tell me. And one more thing, as r is increasing, okay, as r is increasing, the pressure dp is decreasing. So what will we have? We will have a minus sign here. But that is not very relevant because anyways he's asking for a ratio. This minus will get cancelled. So now we can just, after integration, what will we get is p equal to, this is some constant, I'll write it as a constant, k times r dr is r square by 2. So we'll just write this as r square minus r square. That by 2 we'll put in this constant. So we can say the pressure at any point r is proportional to r square minus r square. Okay. So the pressure at any point r is proportional to r square minus r square. So directly what we can do, see the first option, p at r equal to 0 is 0. Is it correct? No. Why? Because pressure at r equal to capital R is 0. So this option is not correct. Next, p at r equal to 3r by 4 by 2r by 3. So what you do is just punch in the values here. R square minus 3r by 4 whole square divided by r square minus 2r by 3 whole square. Like that you just put in the values and you get that B and C are the correct options. Just a minute. Okay. So we get B and C are the correct options of that. Okay. So that was a nice JEE advanced question. And let us now move on to the next question. Okay.